How are you? So we're back and we shall continue our discussion on Precalculus for Quarter 1, Week 1. And today our discussion will start with standard equation of a circle. Okay, so we acknowledge again our writers for Quarter 1, Week 1, Ma'am Juna Marie Casia. Our layout artist is Ma'am JARUDA, and our education program supervisor in math, Dr. Kim ARCEñ. Okay, now, so we already know that a circle is a conic section, a special type of ellipse. Actually, it was mentioned in our previous discussion. So, uh, a circle could either be graphed uh, on a Cartesian plane and whose center could be at the origin or at any point on the Cartesian plane. So if your circle is at the origin, the standard equation would always follow this format: x squared plus y squared equals r squared. So the center of the circle, if the center of the circle is at the origin, the coordinates of the center is noted by h and k. H is for the x coordinate of the center and k is the y coordinate of the center. And every point on the circle has coordinates p, which is xy. All right, now let's have some examples. For example number 1, you're asked to give the standard equation of a circle whose center is at the origin and a radius of 4 units. So following the standard equation, x squared plus y squared equals r squared, therefore you'll have x squared plus y squared equals 4 squared or 16. You may also write it this way. Okay, so x minus h squared plus y minus k squared equals r squared. Since the center is at the origin, so h and k are both zeros. All right, so your final answer, if this is the question, would be x squared plus y squared equals 16. So for exercises 1, you are tasked to answer these items, but I think I only chose number 2 and number 3. Okay, but you may answer all these items if you wish. Okay. Anyway, they are very easy, not that challenging at all. All right. Next, example number 2. For example number 2, determine the standard equation of a circle with the center at the origin. Wait, let's fix our presentation. It's not seen. Okay, let's fix it a little bit. All right, that's it. Okay, now better. So determine the standard equation of a circle with center at the origin and passes through -6, -2. What does it mean when you say the circle passes through the point -6, -2? So in our standard equation, we have x squared plus y squared equals r squared, right? So x and y are actually every point on the circle. So if the circle is passing through this point, this is your x and this is your y on this standard equation. Since the center is at the origin, meaning your h and k are both zeros. All right? Now, so given that the center is at 0, 0 and a point on the circle is given to be -6 and -2. Now, for us to be able to determine the radius r, simply substitute to the equation. So x would be -6 and y would be -2, since x and y are every point on the circle, and negative 6 and 2 passes through, and the circle rather passes through this point, so meaning this point is on the circle. So substituting your x and y values, okay, so this would be negative 6 squared plus negative 2 squared equals r squared. Since we are applying our algebraic rules here, we extract the square root of both sides of the equation. That's why we have this now. So square root of 36 plus 4, we got that from negative 6 squared and negative 2 squared. So square root of 40, by factoring a perfect square from 40, you'll have square root of 4 times square root of 10 would give you 2 square root of 10. So 2 comes from the square root of 4. Therefore, the length of the radius of this circle is 2 square root of 10. So writing now the equation of the circle, we get x squared plus y squared equals square root of 40 squared, or x squared plus y squared equals 40. Okay? Now, for your exercises, you're asked to do one of the following. Okay, so you only choose one here, I think, or two. And then for enrichment activity, you also choose one. Okay, very easy. So just follow the pattern we have done here. Okay, so that's your activity for Q1, Week 1C. Let's proceed to the last page of your Precalculus module. Okay, for Week 1D, our discussion will be on circles having the center at HK. So earlier we talked about a circle whose center is at 0, 0. So this time let's talk about circles whose center is not at the origin, but rather at any point on the circle. So if your circle has a center at any point on the Cartesian plane, then it must follow this standard form. Quantity x minus h squared plus quantity y minus k squared equals r squared, where h and k are the coordinates of your center. Again, h would be the x coordinate of the center, k would be the y coordinate of the center. And if you expand this equation, you expand the standard form of the equation, it will generate the general form of the equation, which would look like this. Okay, so if you expand the standard form, it will become ax squared plus by squared plus cx plus dy plus e equals 0. A, B, C, and D are actually the coefficients, the numerical coefficients when you expand your values here. Okay? We can determine the standard form by completing the square in both variables. So if your standard form is given to be this and expand, it will become the general form. Same manner will be done if you have a general form and you would want to change it to standard form. So there will be some processes involved. So one of those processes would be completing the square, like x squared plus 14x means determining the term to be added that will produce a perfect polynomial square. Since the coefficient of x squared is already 1, we take half the coefficient of x and square it, which is 7 squared, and we get 49. So to complete the square, this becomes x squared plus 14x plus 49, which gives you x plus 7, a perfect square. Okay? How about this one? Okay, so let's say you have such equation. If this is already in general form, you would encounter quantities like this or expressions like this. So how would you make this a perfect square binomial like this one, like this two here? So factor the coefficient of x squared from the expression. There are common monomial factor, which is 3. So 3, quantity x squared plus 6x Then add 9 inside because 6 divided by 2 is 3. Quantity squared would give you 9. Completing the square in the equation, any extra term introduced on one side should be also added to the other side. So the complete square for this would be 3 quantity x squared plus 6x plus 9. All right? Okay, so a little introduction or a little discussion of how this concept will be used later in solving problems pertaining to general form and standard form of circles. All right, let's have an example. So this is an example of a general form of a circle, general equation of, if you have the standard form, we have the general form of the equation of the circle. Okay, so how would you identify the center and the radius if your circle is written in general form? Okay, so like what we have mentioned earlier, we need to do completing the square. Okay, so given x squared plus y squared minus 14x plus 2y equals negative 14, okay, by addition property of equality, you'll have this expression now here. Okay, why do we need to do this? We have to do this because we want this form to be a form similar to the standard form. We will be regrouping them. So by regrouping, meaning arrange the terms in such a way that all the terms having x are grouped and all the terms having y are grouped, and those without variables will be on the right side of the equal sign. Okay, so we have x squared minus 14x, you get this, and then complete the square, you get 49. Y squared plus 2y, okay, complete the square, you get 2 divided by 2 is 1, 1 squared is 1, so y squared plus 2y plus 1. All right, so both terms now are complete. So since you've added 49 and 1 on the left side, we have to add 49 and 1 on the other side as well. Okay, so from negative 14, you have to add 49 and 1 because you have added 49 and 1 on the left side because you wanted this to be a perfect square binomial. All right, now since this is now a perfect square polynomial, it becomes x minus 7 squared, and this would be y plus 1 quantity squared. Negative 14 plus 50 equals 36, giving that, this means r squared is 36, therefore r is 6. And now that we have this form, meaning this is already in standard form, obviously our h is 7 and our k is negative 1. This is y minus negative 1, meaning k is negative 1. Okay, so the circle whose general form is given to be this has a radius of 6 and has a center at 7, negative 1. Okay, I hope that's clear. All right, so for your work, you are tasked to answer on your paper 2 items from this exercises. Okay, I think there are only 2 items given, or I think 1. Okay, so you choose 1 or 2. All right, next, example number 2. The center of a circle is located at 2, 3, meaning h is 2, k is 3. How do I know that? Because it's given to be the center of the circle. Since this is hk, what would be the radius? So we get that from this point because the circle is passing through 1, negative 2. Okay, so how would you find the standard form and general form of the equation? So first, before you're able to get the general form, you have to write it in standard form. Okay, so let's start. Given that hk is 2, 3, and a point on the circle is given to be 1, negative 2, then that would be x, y. So writing it first in standard form, you have to substitute h and k, x and y. So r squared equals x minus h squared plus y minus k squared. This is the standard form of the equation of the circle whose center is at hk, right? So extracting the square root on both sides and then substituting the values. So this is x, that's 1, minus h, that's 2, so 1 minus 2 squared, plus y is negative 2, then k is 3, so negative 2 minus 3 quantity squared. Then simplify, 1 minus 2 squared is negative 1, negative 2 minus 3 is negative 5 squared. Then this becomes 1 plus 25, right? Because negative squared, negative times negative is positive. So square root of 26 would be your r, okay? R is square root of 26. All right? Therefore, the standard form of the equation is x minus 2, we get that from h, quantity squared plus y minus 3, we get that from k, equals 26 because r is 26, therefore r squared is, r is square root of 26, so square of square root of 26 is 26. Okay, actually you may not extract the square root of both sides here because anyway what you wanted to use for the standard form is the square of r, so you may not extract the root anyway here. That would be okay also. Now, so this is now the standard form. We want to get the general form. So for the general form, simply expand these terms here. So a while ago we have completed the square. This time we will be expanding the square. So by using the FOIL method, you'll have x squared minus 4x, that's 2 times negative 2 times x, that's negative 4x, then negative 2 squared is 4. Okay, that's expanding your perfect square. Then y minus 3, do the same thing, y squared minus 6y, that's 2 times negative 3 times y, then negative 3 squared is 9. All right, then 26, then combine terms that are similar, like your 4, 9, and 26. So that becomes, rearranging it, it becomes x squared plus y squared minus 4x minus 6y equals 26 minus 4 minus 9, because you are doing addition property of equality. So you have to transpose this on the other side of the equation, combining it with 26, you get 13. Therefore, the general form of the equation whose center of the general form of the equation of the circle whose center is at 2, 3 and passing through 1, negative 2 is x squared plus y squared minus 4x minus 6y minus 13. This is the general form. This is the standard form. Okay, that's it. For exercise 2, okay, this is the final answer now. For exercise 2, all you need to do is to write the standard form. Okay, so given that r is square root of 26, I think this is very similar to what we have here. So just write the standard form, all right, and then choose one from the enrichment activity. I'm only asking you to choose one, okay, any one of this. So if you choose this, it's either 1 or 2, or if you choose this, you have to answer this one. Okay, I hope this video helped you in answering our MathPACKS for Precalculus Q1, Week 1. Okay, enjoy working. See you on our next one. Bye.